Okay, we're here with 4.7 and we're going to be solving inequalities today. Now, when we solve inequalities, we treat them almost the same as we do equations except for one thing. And let's go through some of the steps on how to solve equations. Remember, when we solve equations, it tells us that we can add the same number to both sides and it still maintains the same answer. The same with this. So let's start with something that's like 2 is less than 3. That's a true statement. 2 is less than 3. If I wanted to add 1 to both sides, is this still going to be a true statement? Well, 3 and 4, 3 is less than 4, so that is a true statement. With the solving of equations, it says that we can subtract the same number from both sides and maintain a true statement. So let me see if that works. If we have 4 less than 5, if I subtracted 1 from both sides, that would be 3 and that would be 4. Yes, that's still a true statement. What about if we multiply? If I have 2 less than 3, if I multiplied by a positive 1, that would be 2 and 3. And yes, that maintains the same, it's still true. It doesn't matter if it's a positive 1, positive 5, positive 10, it's still going to be a true statement. If I divided, let's do another number here, 4 less than 8. If I divided by a positive 2, then this would be 2 less than 4. That's still a true statement. So if we add or subtract the same number from both sides, or if we multiply or divide by a positive number, it still stays the same. Now, I wonder if anybody picked up that I keep saying a positive number when we multiply or divide. But over here for adding and subtracting, I said just add or subtract any number. Over here, it stays the same if we multiply or divide by a positive number. Well, that hopefully leads you to think, well, what happens if we multiply or divide by a negative number? Let's try one and see what happens when we multiply or divide by a negative. Now, I'm going to have 4 and 10. I'm just going to compare these two. 4 is less than 10. It's the same, right? So what if I multiplied by a negative 2? Multiplied by a negative 2. 4 times negative 2, positive 4, negative 2 is a negative 8. Over here, 10 times negative 2 would be negative 20. Now, I'm looking at this inequality sign. We started out by pointing towards the left. Now, let's compare this. Which one of these two numbers is smaller? Is negative 8 smaller or negative 20 smaller? Negative 20 is smaller, so we point towards the negative 20. Notice how when we multiplied by a negative number, the inequality switched directions. So whenever we're solving inequality, we're going to solve it just like an equation, except when we multiply by negative numbers. When we multiply by negative numbers, we're going to change the direction. Same thing for division. If we are dividing, I'm going to start a new problem here. We have negative 8 is greater than negative 20. We just wrote that down there. If I'm going to divide by a negative, we'll go with negative 2. Why not? I'm dividing by a negative 2. Now, I just said that when we multiply or divide by a negative, we're going to change the direction. So I'm going to go ahead and write that down, and I'm going to go, is that true? You're going to tell me. What is negative 8 divided by negative 2? That's a positive 4. Negative 20 divided by negative 2 is a positive 10. Is this a true statement? 4 less than 10? Yes, it is. So see how we changed the direction here? This was pointing towards the right, and now it went towards the left. The only time we change the direction of the inequality is when we multiply or divide by a negative. Don't shortchange and say when we multiply or divide, because that's not true. I showed you that when we multiply or divide by a positive number, the inequality stays the same. It's when we multiply or divide by a negative number that you change the direction of the inequality. So let's solve a problem here. So once again, when we multiply or divide by a negative number, we change the direction of the inequality. So let's do number 7, which is 9x minus 5 less than or equal to 8x plus 3. We're also going to graph it and write an interval notation, because we need to practice that. All right, so the first thing we do, we're going to pretend it is an equation unless we're multiplying or dividing by a negative. So I don't do anything with this unless I'm multiplying or dividing by negative. So here we go. We're going to subtract 8x, and I have x minus 5 less than or equal to 3. because I didn't multiply or divide by a negative, I subtracted it. Now I need to add 5. X is less than or equal to 8. So now I have my statement. I can graph it. I want to make sure I have 8, 9, 7, 6, 10. What am I going to put here at this 8? I'm going to put a closed circle because it has this equal sign. So there's my closed circle. So now I need to decide, am I going to shade this side or this side? There's 2 ways to tell, but I prefer you to make sure you read it to make sure it's true. Since X is on the left side of my statement, X is less than or equal to 8, I can shade the direction that this is pointing. So I shade it this way. Let's change colors again. I shade it this way. But I want you to test it. Test the point. Pick one. Say 6. Is 6 less than or equal to 8? Is that a true statement? Yes, then yes, we graphed it correctly. You always want, it does not take long to just pick a number and throw it in there and see if it works. All right, the last thing is interval notation. I said it's always easier to graph it first and then write interval notation. Where's my solution start? I'm way over here off screen. I'm way over here, in what land am I in? I'm in the negative land. I'm as far to the negative side that you can possibly be, which would be negative infinity. So what do I put around negative infinity? Interval notation is always going to have a parentheses or bracket and separated by a comma. So this is a negative infinity. I cannot nail down where negative infinity is, so I put a parentheses, comma. Okay, I'm coming along here, coming along here. Where's my solution? My solution stops at 8. So I put an 8. Is 8 included in this answer? Meaning, can I say 8 is an answer, or do I just get as close to 8 as possible? I have a closed dot. I have an equal sign, so that means I put a bracket. See how this is a straight line? I kind of refer that to as like my equal sign. 8 equals the answer. So there is question number 5. Let's pick another one. Number 7. Not number 5. Number 7. So I'm going to move over and do one a little bit harder. I'm going to do number 15 now. So look over on the other page and let's do 15. All right, we're continuing on with 4.7. I have number 15 out of our packet up here on the board, and I'm going to solve it for you. We're going to make use of the same rules as we do as in equations, except the only time we care about that inequality, doing something different with it, is when we multiply or divide by, you guessed it, negative integers or negative numbers. It could be negative fractions, negative decimals, negative anything. If you multiply or divide by a negative, you must change the direction of that inequality sign. So following the rules of equations, we're going to simplify each side. The first thing we do is we clear any parentheses. So on this left side, I see this parentheses. I look outside and I see, hey, that's being multiplied by what? A negative 7. So I'm going to distribute that in there, and I would have 8x minus 7 minus 7x greater than or equal to. On the right-hand side, I'm going to clear that fraction, and I have a 3 I can distribute, and this would be 3x minus 6 plus 2x. So now the next thing is on that how to solve equations is a general strategy is, do we have any fractions or decimals? No. Can we combine like terms? Yes. I can combine 8x and negative 7x to just get x on this side. And over here on this side, I have a 3x and a positive 2x. That would be 5x's minus 6. Now I've simplified both sides of my inequality. Now I need to move my x's to one side and my non-x's to the other. It does not matter which side the x is on. A lot of times teachers or just people in general want to have the x on the right side. It does not matter. You will get the same answer, but we will, I'll show you that we would get that. We'll subtract my 5x on both sides. X minus 5x would be negative 4x minus 7. I did not multiply or divide by a negative, so the inequality stays the same. Now I need to add the 7 to both sides, negative 4x, and this would be greater than or equal to 1. Now remember, we're down to where we have it variable, non-variable, so I need to divide by whatever is in front of the variable. So that would be divide by a -4. Divide by -4. I'm dividing by a -4, so what does that mean? That means we flip the inequality. So this one is pointing to the right, so now it's going to be pointing to the left, and this would be x, and over here this is just -1/4. Remember, we like that negative sign to be either in the numerator or just out front. We do not like to keep it down here in the denominator, so he needs to either move up front or be out front. So positive divided by negative would be -1/4. And there we have our solution. X is going to be less than or equal to -1/4. So let's graph this problem. Let's see, can we get on the page here? Yep, I'm on there. So I need to have a -1/4, and that means I have 0 over here, and over here I can have a 1. It really doesn't matter. -1, excuse me. And -2, and we can have 1 up there. All right, so what am I going to put at this -4? I'm going to put a close the dot. Let's put a different color so we can see it better. Close dot. And then remember, when the variable is on the left side, and this is why we like to have the variable on the left side, when it is on the left side, we can draw the line based on which direction this is pointing. So this is pointing to the left, but as I always say, don't just depend on that. Let's put a number in there and check to see. Let's pick -1, because that's in the graphed area. Is -1 less than or equal to -1/4? Yes, it is. It's farther to the left on the number line, and it's bigger. So there we have our graph. So the next thing is our interval notation. Interval notation, we're going to start, where do we start at? All the way over here on the left. And I'm way down into negative infinity land. What kind of symbol do I put here? Do I put a parentheses or do I put a bracket? I put a parentheses and I put a comma. And then where do I stop at? I stop at -1/4. Is -1/4 included, or are we just toeing the line, getting as close to -1/4 as we can? Close dot, equal sign, bracket. And now we have our graph and we have our interval notation. So that's the finish with that. And I would like you to, my next video, I'm going to show how to work out questions number 13. No, don't make that. Yeah, 13 and 17. I'm going to work on 13 and 17 of 4.7. 4.7, number 13 and 17. I would like you to take time to try it before you watch the next video. All right, next time I come back, I'll be working those two problems.